Good morning, everyone, and welcome to our last week, week 13. It's a revision of last 5 weeks, what we have learned from week 8 to week 12. Today, we are going to have a kind of quick revision. We will not go in depth once again, but yes, we'll try to do some of the exercise at random altogether so that you can the ideas and the concept and the application can be reinforced in your mind. You maybe today's session will give you a little bit more kind of logical uh, connectedness in between the various construct or various concept which we have learned. Meanwhile, I request you to just mark your attendance in the chat box. If you have not done it, please do that. And I hope you guys are able to see your all quiz 1 to quiz 6 plus midterm test marks along with all your attendance. I used to update on the same day. So I'm sure like we all are in the same track. I mean to say you don't have any confusion in terms of your marks, midterm or quiz and attendance. So everything is updated. So please go through that and when we like be agree on that, because if you think any discrepancy or anything something is wrong or you're feel free to get back to me. uh, so one thing, I'm assuming that you have gone through the exam instruction which I have uploaded on the Moodle, and someone of were asking through the mail that where is the answer sheet, like the template for the answer sheet. I said it is already there on the Moodle under the announcement, and you will have the same uh, Word documents for the answer sheet. So please download it in advance, because I'm not going to send you separately that answer sheet template through the personal email. So it is there on under the announcement. So just download it and keep it safe. And once again, the request is like just provide your answer sheet in either in the Word file or the PDF file. Other files will be not supported in my system or not even the NIC system. So just keep that in mind. The kind of file as an answer sheet you are sharing, it has to be like accessible for us to the tutor. Otherwise it will be a kind of distrust or something. So better just try to avoid that in order to have any negative consequences on your performance. uh, in addition to that, with the communication with some of you the last week, I came to know that I forgot to add one more material which is allowed during your exam, and that is one blank page sheet for the rough work and calculation. So you are allowed to take or keep one blank sheet. Uh, you are allowed to permit like and take the calculator, but along with that one blank page, keep that one in the mind. One blank sheet back to back, like just for your to support you during your when you do the rough work or the kind of calculation. So maybe it will be required. So I forgot it, but now I added it and I communicated you again with on the Moodle, and probably I will communicate the same thing to the invigilators on that particular day who will be there. So they will be knowing that you are allowed to have a one blank page sheet for the rough work and calculation. Oh, hope everything is fine in terms of instruction and instruction for the exams. And let's see what we have today is like in the today's session. So as I said, today's session you're probably not going to learn anything. I mean to say the course content has been covered, so we are not going to have anything in terms of new learning in today's session, and not even during the tutorial session. So it's a kind of recap whatever we have learned in the past. We will have lots of discussion around that one, what we have already learned. Probably some of you who are still struggling with some of the concept and all, today you have a chance. You can ask in between, uh, so that I can provide you with in any different way. I can let you understand that concept and application. Otherwise, if everything goes fine with you, be happy, and probably you will be able to grab, or you will be able to get good marks in the final term exam. So keeping that in a note, I assume that today's session is important for those, like for everyone. So maybe those who are struggling, for you, it's again another chance to get the things clear. And for those who are already on the right track, it's a kind of it will help you to kind of build up more confidence, because you will think about everything is all right for you. So it's fine. So you remember the week 8 to week 12, what are the different concepts we have learned in this today's session, in this session, like in the classes of in the class of statistics. uh, are you able to recall where we started, like in terms of week 8, 9, 10, 11, and 12? What are the different concepts we have learned together in this statistics class? So I'm trying to give you a kind of a small recap. Let's switch to the smart board, the whiteboard. Okay. So talking about the week 8, week 9, week 10, week 11, week 12. Week 8, we started with the concept of confidence interval. So confidence interval estimation. Confidence interval estimation we started. Then week 9 and 10, yeah. So we started with the confidence interval estimation, where we have seen the three different varieties of exercise. One is for the proportion. Second one is whatever we are discussing today will be a part of your end-term exam. So just have a kind of more focus. So CI estimation, we learned for the proportion. Then mean, for a single mean where the sigma is known, and again for mean where we have seen sigma is unknown. That we have covered in the CI estimation. Probably it was 8 and 9 together, or maybe, okay. So we understood that one, CI estimation. 9, 10 together, we started with the hypothesis testing. Hypothesis testing we started, and where we have seen hypothesis testing for the single mean. Single mean. No discussion on the independent mean or the dependent sort of sample. So I took you in greater detail in terms of covering two different lecture 9 and 10, so that you can have a better understanding on the hypothesis testing. Then we had a week 11, where we had an advanced level of advanced understanding of hypothesis testing, where we have seen independent and dependent, more than one mean, right? Where we have seen two samples could be dependent or independent. So we have seen the different categories in terms of separate t-test, variance, also pool test, and also we have seen the dependent, where we have seen the how to formulate the hypothesis in terms of the differences between two samples. Okay. And finally, if you could remember the week 12, we had a discussion on correlation and regression. Okay, one important point over here is for the hypothesis testing. I'm not going to repeat this one again. For the hypothesis testing, I have not covered the proportion. So probably there will be no question. I mean to say there is no question. There will be no question in the exam on the hypothesis testing of proportion. So you can exclude it. I think the tutorial exercise 11, it covers 4 or 5 sums exercises on the hypothesis testing of proportion. So you can exclude that for the exam purpose. For understanding, you learn it, but there will be no question on the hypothesis testing on proportion. But keep in mind, CI estimation, we already covered the proportion. So there should not be any confusion. And if there is a confusion, please ask. Either you can ask, you can unmute and ask, otherwise you use the chat box so that we can have a conversation. So 8, 9, 10, 11, 12. So we started with the CI estimation. We moved to the hypothesis testing and then correlation and regression. Remember, like when we started the CI estimation, probably we were not knowing much about the application of the concept CI estimation, confidence interval estimation. Even when we were doing the hypothesis testing, probably we were not knowing much in terms of the application. We understood that there is a claim and we wanted to see, we wanted to check, is it the claim is supported or not supported? I mean, just 1 second. So we wanted to see that is that claim is supported or claim is not supported. That's what we were knowing. But when we did the correlation and regression, what we found? We found that there is a application of both the concepts, CI estimation and hypothesis testing, is being covered when we were trying to understand the regression altogether. So in the case of regression, if you recall the regression output, what it shows, regression output somewhere it gives you the CI estimation. And also it talks about the significant F, which is more as a like hypothesis testing. So when we were doing the regression analysis, we have seen that there is application of the both the application of both the concepts, CI estimation as well as the hypothesis testing. Remember the kind of question is that regression line is reliable, or is there any validity of the regression line? So those sort of questions deals with the concept of CI estimation and hypothesis testing. So you remember, like what you can see, like we started with the CI estimation, hypothesis testing, and then advanced level, and then finally regression. So when we ended with the regression as a concept, we have seen the integration of all these concepts coming together. All these concept it can be understand in terms of regression. So in order to understand the regression, it's important to understand clearly what exactly the meaning of CI estimation, hypothesis testing, and then correlation, and finally regression. So somehow you try to see in a kind of holistic way, try to understand in a kind of systematic way, and you will see that all these concepts, it is bound together. All these concepts are interrelated to each other. So it's important to have an understanding of all these three major concepts: CI estimation, hypothesis testing, and regression all together. Otherwise, it will be difficult to look at in terms of application from a single lens. So it's better to look at all these concepts, which we have covered from week 8 to week 12 in a combined way. So it will increase your kind of understanding, in-depth understanding in terms of the concept of regression. Hope to some extent it makes sense to you. Is there anything which you wanted to add? You wanted to discuss? Otherwise, I will start with the kind of small revision with around all this concept.
Can you please tell that from week 11, which questions of which tutorial we should skip? As you said this, that there are 4 questions from proportion.
Yes, hypothesis testing, proportion. There are few questions on the
yeah, there are 6
11.
questions.
Yeah.
So which 4 we should skip?
No. I mean to say the proportion is not there. You can escape the whole.
Okay. Yeah, that's the thing.
It's not like 4 or 6. It's a kind of this concept. The hypothesis testing for the proportion I have not covered in the class. So you can escape it. See, almost it is the same thing. For your learning, you can go through. That is not a problem. But in the exam paper, there will be no question from the hypothesis testing for the proportion. But proportion is covered in the CI estimation as a concept. So you know what I'm saying now, I think.
Yeah, okay. Thank you.
So going back here, week 13 revision. So what I did is like I have selected some of the exercise as a revision, so that we will do together across all the 8 to 12 different weeks, whatever we have covered. So let's start with the week 8. So we started with the CI estimation for proportion, CI estimation for the mean, where the sigma is known, and the CI interval estimation for the mean when sigma is unknown.
Sir,
Yeah,
for the
go ahead.
exam, um, are we not gonna have a lot on week 1 to 7's content?
No, I said like probably it will be a kind of multiple choice MCQ. It will cover a little bit,
Oh, okay.
not in the
But it's
detail. Yeah, because
mostly
the
on week
purpose is
8.
to evaluate you on the total learning, right? So week 1 to 7 we have covered during your during our midterm exam.
Oh, okay. Yeah.
So if I will repeat and I will give a less weightage to the end parts and section, whatever we learned from week 8 to week 12, it will be not a kind of proper justice. So idea is
Okay.
there will be a kind of MCQ will cover all those one. So just have a small revision around that one, week 1 to 7.
There will be no calculations.
I mean to say the MCQ, you know,
Yeah,
like
okay, yeah.
it will cover
Okay.
it as a part of MCQ. There will be no as question as such. But keep in mind the basic concepts are always relevant. So just have a kind of revision around that.
Okay, yeah.
Okay. So now I think by this time you have understood the importance of sigma known and sigma unknown. So whenever the sigma is known to you, probably we use the Z statistics, Z table. But whenever is the case when sigma is unknown, so instead of sigma, what you have capital S, that is the standard deviation for the sample. And in that case, always we prefer to have t-test. So there should be no confusion in terms of in which application, in which exercise I will apply z-test or t-test. It's very clear. Sigma is your standard deviation for population, whereas capital S is the standard deviation for sample. So whenever something they talk about sample, keep in mind you have to apply t-test, t-statistics, t-table, and the degree of freedom. All these things should come in your mind while attempting that question. But if that is not the case, sigma, clearly it will be mentioned sigma as a notation or the symbol, or maybe the standard deviation of population, word population will be there with the standard deviation. That is the sigma. So if that is the case, apply Z statistics. Okay, I'm just trying to reinforce you. I know you guys are now able to understand and differentiate, and many of the students, many of you have scored very good marks in the last three quizzes. The quizzes for like 4, 5, 6. I've seen the kind of your performance has grown. So I mean, like you guys are doing really hard work. That's why you have a good result in your hand. So congratulations for that. Okay, just a kind of small recap: sample estimate and population parameter. You should not get confused. Even after completing this statistics classes, you should not get confused with these two things: a sample estimate and population parameter. And using the sample estimates, we are trying to make an inference about, we are trying to say something about the population parameter. Why? Because most of the time, the population, the members of the population is not known to us. If I wanted to do a kind of survey and analysis of the Australian people during the phase of coronavirus, how much, to what extent they are satisfied, I can't take a whole, I can't go to each and every individual household in Australia. So I will take a sample somewhere, maybe the New South Wales, or maybe more specific to Newcastle, or maybe the other states. And then using that sample estimates, I will try to generalize something about the Australian population. So the estimate is clearly different in compared to the population parameter. So whenever we talk about estimate, mostly we talk about sample. So sample mean, that is X bar. So if suppose in the exam you have to write X bar, you don't think about the notation. Don't look at the where is the notation for X and then bar. No, just write X VAR bar. Just convert in the layman. I will be there to answer you, check your answers. I will understand. For mu, as I said in the last one, mu will be fine. No need to look at where is the symbol mu in order to write, because you have to provide your answer in terms of not in the writing handwritten. It has to be typed on the word file or the. So just keep that one in mind. P bar or P hat. Okay, P hat hat or bar. I will understand that. So that is, but you should keep that one in your mind. Don't say later on that I was struggling to find, and that's why I, instead of P bar, I have written P. I will not give you the marks in that case. Indicate clearly, because it's a kind of communication we have to exchange in a proper way. So understanding the importance of sample estimate and the population parameter, using the confidence interval estimate, or using the sample, we were trying to make an inference for the population parameter. For the confidence interval, probably I suggested you to understand the importance of alpha. Later on, we understood in the hypothesis test that alpha is actually the significance, level of significance. So for 90% confidence interval, level of significance will be 1 minus 100, and 100 minus 90 divided by 100, so 0.10. For 99, it is 0.01. So that you understood. Always in the CI interval, or maybe then the hypothesis, always we have an understanding of the critical value. Critical values are very important because it separates the region of rejection and region of non-rejection. So the critical value, in the case of Z statistics, go through the table, find out the critical value. Or probably we have, in the case of Z states, we have clearly, if you see, these are the critical values. So just take it blindly, remember it, because it's easy to remember 90, 95, and 99%, 1.645, 9.96, and 2.5. So it's easy to remember the critical value in the case of CI interval. So what I was telling, that critical value, you have to see the Z table for the proportion and the other thing. But in the case of T stats, you have to find the T corresponding critical value using the T stats. So critical value is the value or the point which separates the area of rejection, area of non-rejection. So your T values or the Z values, if it falls right to the critical value or area of rejection, just reject the null hypothesis. So keep in mind, area of rejection or area of non-rejection, we are talking about null hypothesis, not the alternative hypothesis. So null hypothesis, reject. Null hypothesis, not reject. We have seen the importance of margin of error, because when we were calculating the interval, confidence interval estimate, we were trying to, like for that calculation, what is important to understand, the margin of error. So mean minus margin of error, mean plus margin of error. That is the confidence interval estimation we are trying to generate. And for calculating the E, margin of error, we have the formula Z alpha by 2, P hat, in the case of proportion, P hat 1 minus P hat divided by n square root. So probably you have the similar sort of formula for the later half, where we are using P 1 minus P divided by n. So be careful in terms of you need to be careful, because sometimes in some other calculation, P hat, instead of P hat you have P 1 minus P. So don't get confused. Although all the formulas will be given to you at the end, but better you practice it, so that there should not be any confusion at the end. So let's go through quickly one example, like exercise 3, slide number 24. Okay, let's go through this one. It's a quick example. Let's see, are you able to do it without any hassle? The operation manager at the large newspaper wants to estimate the proportion of the newspaper printed that have a non-conforming attributes such as excessive rub-off, improper page setup, or missing pages. A random sample of n equal to 200 newspaper is selected from all the newspaper printed during the single day. In that simple sample, 35 contains some type of non-conformance. Construct and interpret a 90% confidence interval for the proportion of the newspaper printed during the day that have a non-conforming attributes. So you are an operation manager. Millions of the newspaper you are printing every day, but you can't include everyone in your sample. So what you did, you just took as 200 sample. And out of 200 you found 35 has a non-conformance, like some fault in the paper. And then you wanted to plot a kind of in which interval you could say that with the confidence that the mean will come in this interval, something like that. So how we proceed for this one? Can we clearly see that this is the case of proportion? Yes. Proportion is what? A fraction or a percentage. So whenever 10% is given, think about that. Or otherwise, instead of percentage, it will be a kind of, it will give you a kind of indication towards the fraction. What is fraction? The item for your interest by total items. In this case, item for my interest is 35 because the 35 contains some sort of non-conformance. So that is our interest. Divide by total size of the sample, that is 200. So 35 by 200 is your proportion, is your p hat. So what you need in terms of constructing the confidence interval, you need p hat. We have seen the formula here. P hat 1 minus p hat by n. So in that case, what is the n size? Size is 200. The sample size they have taken 200. So you should not be confused with 35. 35 is not your sample size. N is your sample size, which is clearly mentioned here in this case, 200. So p hat is 35 out of 200. So 35 out of 200, how much is the percentage? Or how much is in terms of 35 by 200? It is 17.5.
Yeah.
So, yeah. So just try to solve that one because it's a 2-hour session, so it's better to do some exercise altogether. So go through this question and try to do it once again. The operation, the exercise number 3. Meantime, let me rub this one. Good. Which one was good then? Yeah, I think so. This one. So exercise number 3. What is the p hat? So 35 by 200 and 99%, 90%. So the confidence interval alpha value is 0.10. It is given 90%, so 0.10. And you have, so I'm writing here, see the p hat. So this is writing a p hat or p bar, or like p hat is fine. P hat equal to 35 by 200. So that gives you kind of 17.5, so 0.175. Then at alpha is 0.10. So what is at the 90% confidence interval, what is the value of Z alpha by 2 using the table? It's a 2 point, anyone? Or
645.
1.65, right?
45, yeah.
1.65. So what is the next step? Find the, what you have to find? The margin of error, right? So what will the margin of error? Z alpha by 2, 1.645 into p P hat. Remember that P hat is 175, 1 minus 175 divided by n equal to, what is the n equal to 200. That is your margin of error E. And what will be the final answer? The final answer will be X bar minus E, X bar plus E. What is X bar in this case? Is that given?
Sir, isn't it P hat plus E and P hat minus E? Because we're working with proportions, not mean.
Okay, okay. Let me go through that one.
It's P hat minus C, P hat plus C.
Let me see that. I think so. Both are the same thing, but it's better to make it as a minus and plus. So instead of X bar, we have P hat. Yeah. So it's not X bar here because this is not the case of mean. This is the case of proportion. So instead of X bar, we have P hat. So P hat minus E, P hat. I think this is the calculation. Any doubt here? You wanted to have somebody say, suggested me, you can do it as a P hat plus minus E. Absolutely fine. Take 1 minus 1 plus. Same thing. Isn't it? Right?
Yeah.
Both are same thing. So either you can, I will suggest you to stick on this one. Just give a kind of clarity without any. So sometimes, you know, if there will be a minus value or something maybe. So it's better to stick on this one. Probably this may give you kind of confusion, but it's better to stick on the P hat minus E, P hat plus E. So that is the range for the confidence interval estimation. Next question is how to have like what kind of interpretation you can make in that one with that findings. So that interpretation, as I said, is always important. So in the exam, if I'm asking you find out the confidence interval estimation, after providing the answer, you must interpret it. There will be no question like, can you provide this interpretation? If you are writing a confidence interval estimation, please have an interpretation in a single sentence. So for this example, for the exercise number 3, see the screen? We got a interval of 0.1308 to 0.2192. So how to make an interpretation for this? So what you can conclude that with 90% confidence that between 13.08 and 21.92 of the newspaper printed on the day have some kind of non-conformation. I mean, we are 90% confident that the interval 13.08 to 21.92 does contain some sort of non-conformance. It has to be in your own word. So at least it should cover the term 90% confidence and the interval.
So, sir, in the exam, that's how we have to word our conclusion, because when we were doing exercises back then, our conclusion was just like, we are 90% confident that like 0.1308 to 0.2192 does contain the true value of the population proportion. So it can't be that one.
Yes, yes.
It has to be something like this.
Yes, yeah, something. But you must give a kind of interpretation. You should not, you know, it's not like this is the interval, finished. No, don't.
Yeah. Okay.
Since I'm assuming that you guys understand that one, so it's better to provide the answer as with more and more clarity. That is the thing.
All right.
So the proportion is clear?
Yeah.
Okay. Then after the proportion, we move to the mean, CI mean, where the sigma is known and sigma is unknown. And for that, we have 2 different exercise to do as in terms of revision. The first one is exercise 1 on the page on slide 37. Okay. Exercise, yeah. What do you think? In this case, read the question. Is the case of CI estimation Yes. Construct 95% confidence interval. This is the case of CI interval. In the CI interval, we have three categories: proportion, sigma known, sigma unknown. Which category this question is? Decide that and then just go ahead and find the answer. So what is given in this question? The paper manufacturer has a production process that operates continuously throughout an entire production shift. The paper is expected to have a mean length of 11 inches, mean length, X bar. So while you read, you make a note of something, what is given, X bar. Mean length is 11 inches. And clearly it is mentioned sigma is given, a standard deviation of, it's a sigma, standard deviation of population. So 0.02. At a periodic interval, a sample is selected to determine whether the mean paper length is still equal to 11 inches or whether something has gone wrong in terms of the production process to change the length of paper produced. You selected a sample, random sample of 100 seeds. So next is 100 seeds. So n equal to 100. And the mean paper length is for the sample, sorry. So this is not X bar. Did you get that? I did some mistakes. Do you think it's X bar? Anyone?
No, it's the mean.
Yeah.
Very good. Very good. So that's, you read it again and again and find out. So that is mu. That is the population for the, the mean for the population. But for the sample of 100 seeds, the mean paper, mean value is given now. It's 10.998. 998. And then construct 95% confidence interval. So clearly this is the case of where sigma is known. And sigma is known, you have to use which formula? Let me see that. Yeah, it's very simple. Z alpha by 2 into sigma divided by square root of n, if sigma is known. And if sigma is not known, instead of sigma, you will have capital S. I think it's very simple. So can we get the margin, how to get the margin of error in this case? Let's go through the board. Do this question then. Let me see that. Where is that question? Sorry, I have all the data here. Okay. So exercise number 1. So you need to find out E, margin of error. E is given with the formula Z alpha by 2 into sigma divided by square root of n. What is the Z alpha by 2? At 95%, what is the value? Anyone?
1.67.
1.67?
1.67.
Yeah, 1.67 into sigma. Sigma is given standard deviation. Sigma is given, 0.02. 0.02 divided by square root of n is given 100.
Sir, sorry, where did you get 1.67?
That is Z alpha by 2.
For 9.
Not 1.96.
Yeah, I think it's 1.96 for 90%.
Yeah.
Let me go through that. Yeah, for 95%, 1.96. Okay, 1.67. There is nothing like 1.67.
Okay.
It's like 1.645 for 90% and 90. I think. Should not get confused. It is there. So 1.96. And then finally, you have the what will be the interval? Since x bar is given, right? Somewhere, yes. X bar minus E, x bar plus E. That will be your interval. Confidence interval estimation. Only three different values, 1.64, 1.96, and 2.57. So you can make a note of somewhere. Okay, so go back here, exercise. No, exercise 1. So construct a 95% confidence interval estimate for the population mean paper length. So this one is the answer, x bar minus E, x bar. And all the data has been given.
Sir, sorry. Can I just ask about that exercise? When you do like the x bar plus E and x bar minus E, aren't you gonna get over like 100%?
What is 100%?
Like what? So what's the confidence interval that you would get there?
We are 95. In this case, we are 95% confidence that we will get the mean value will lies in this interval. We are 95% confidence that mean value will lies in this range, lower to upper.
Okay, okay.
Does that make sense?
Okay, yeah. No, I see the conclusion now. It's making sense.
Yeah, you see here the managerial interpretation. Thus, with the 90% confidence, you conclude that the population mean lies between 10.094 and 11.
Okay, yeah. Okay, okay.
And see the further interpretation is very, very important in terms of managerial decision making, because the interval includes 11. This one point is very important. Because the interval includes 11. 11, what is 11? 11 is the mean of the population. The value indicating that the production process is working properly. So you have no reason to believe that anything is wrong with the production process. Isn't it some sort of kind of hypothesis testing? If some manager is trying to see that is there anything wrong with the processes or not? So it gives you kind of indication that this sort of kind of findings has a managerial implication. So the mean of the population lies in this interval, everything is fine. But if not, then something is wrong with the production process. There is a need and there is a requirement to change or monitor it or something like that. So this sort of decision, this sort of reports as an operation manager, you will give to your operation head. Operation head will talk to the C-level executive. And then accordingly, if there will be a requirement of having additional resources to have a kind of investment in terms of quality management system or something will goes on the build-up of this finding. Third one, when sigma is unknown, and for that we have exercise number 3, slide 52. Okay, go through this one. The average of a random sample of 10 scores on a college placement exam is 75, and the sample standard deviation is 8.4. So no, there is no discussion about sample like standard deviation of population sigma. So clearly this is the case of sample standard deviation where S is given, capital S is given 8.4. So in the previous example, instead of S, sigma was given, but in this case capital S is given. Assuming that the collection of all the scores is approximately normally distributed, then find a 95% confidence interval for the population mean score. So this is clearly the case where sigma is unknown. And since sigma is unknown, capital S, instead of sigma, you have capital S. So how to get the margin of error? How to get margin of error? E in this case, it's showing that T. So clearly, as I said, this is gonna be a T statistics at n-1 degree of freedom. So T alpha by 2, capital S divided by so this portion is the same as the previous one, where we were having sigma divided by square root of n. Instead of T alpha by 2, it was Z alpha by 2. So looks like similar, right? But the application of T starts here. What is the S value is given in this sum? Exercise number 3 we are talking about. So what is the standard deviation is 8.4. So this is 8.4. What is the sample size? Random sample of 10 scores. So it is by 10. You need to find T alpha by 2 at what degree of freedom. So you know that. Use the table, find out the E value, and what will be your interval estimate. What is given to you? The average of this. So it will be X bar minus E and X bar plus E. Find out that X bar minus E, X bar plus E. What is the T alpha by 2 in this case?
2.622.
2.2622. Let others to get this value.
2622.
2.2622. Others, are you able to see this value using the table? Use the table. Let me see that. Probably those who are struggling. Let me go through the table. Let me open that table. T-stat table. In the exam, I have given you only one version of table, because the second version I have uploaded later on, so it will be not there. So you can keep a soft copy in your system. That is not a problem. The one which I have given you in the exam, I'm showing you. This table will be given, a single page table for the T-stats. But later on, I have given you the 2 pages also. So it's better not to take the print out because it's a closed book, so, but you can keep it in your system. Does that make sense?
Yeah.
Yeah, so don't take print out because it's a clearly mentioned it's a closed book. Nothing has to be there around you. The camera can capture everything. So better to be safe, but keep it in your system and do that. That won't be a problem. So over here, the T alpha by 2. How did you get that T alpha by 2? At the 9 confidence interval?
And 0.025 where they meet.
Yes, 0.0, because the alpha is given 95%. So alpha is 0.05. So alpha by 2 will be 0.025. So you see here, if I can do a little bit drawing here. You can see degree of freedom is 9 because the sample size is 10. And over here is alpha by 2.025. So let's draw one horizontal line and one vertical line and see where it meets. So this is the value of your T alpha by 2. That is 2.2622. 2.262. Yeah, 2. So you have T alpha by 2, 8.4, and then get the value and just have an interpretation. So I think with that, week 8 is, this is the summary of the week 8. In a single slide, everything is covered, although all these things will be provided, but keep in mind, but you should not take any printout. keep your slides and everything in system, fine. Nobody's going to see that. So these three are the major ones.
So, sir, is it okay to check from the soft copy?
Could you repeat once again?
I'm saying that if we check from the soft copy, so there would be no problem.
Yes, exactly. In your system, if anything is there, who is going to see that?
Okay.
But don't take printout because it's a closed book.
Okay, no worries.
But what I said, all these formulas are given at the end of your question paper. Read the question paper. You will see the question paper will be in the 4 pages, but remaining 8 or 10 pages are like full of formulas. All these formulas are there. But in
Okay.
case, if you think that you wanted to refer it immediately, then you just keep it in the system and soft copy. But keep it a precise version, not the many thing. Although the same thing will be provided, but just for your own advantage. That's it.
Okay, no worries.
But nothing has to be, because it's a closed book, nothing has to be in terms of printout, except the 1 page blank pages just for the calculation using the hand. Otherwise, don't. So
Okay.
this is the like the crux of all the discussion which we had in the last 50 minutes. Okay, with that note, we are moving now to the hypothesis testing. Hypothesis testing, let's go through the, first we'll go through the single population mean, where we'll see one example from sigma is known and sigma is unknown, and another one is sigma is unknown. So let's go through the exercise number 6. That is the slide 82. Okay. Read this question. Looks like heavy content and all, but it's easy since you understand the concept of hypothesis testing. Once you read, you will find that okay, there could be a not relevant data in that, but still you have to capture those relevant information which are important for the calculation. So read that this question, exercise number 6. The Nielsen Company is a global information and media company and one of the leading supplier of media information. Nielsen is a very good, very renowned company in the marketing research and consultancy firm as a firm. In the state of the media report, they announced that US mobile phone subscribers average 5.4 hours per month watch videos on their mobile phone. So the population distribution of the hours follows a normal distribution. So the 5.4 is the population mean for the population mean, 5.4. And then later on, they are talking about the sample. So the sample of 8 adults was randomly selected from the target population. It was found that the sample had a mean value. So here it is given the sample mean, X bar. But before that, it was population mean, mu. So the sample mean is 7.16 hours, where the sample standard deviation is also given. So remember, sigma is unknown because instead of sigma, capital S is given to you. Sample standard deviation, not the population standard deviation. So capital S is given. And since it is a capital S, it's clearly the case of T stats, not Z stats. Sample standard deviation is 3.56. And then there is a claim that this sample differed from the reported average of 5.4 hours. We will trace this claim at 5% significant level. So, seems like lots of information, but if you put it on the paper, probably you will have a kind of precise understanding of what their question is all about. So 5 points. So what is the claim? So null hypothesis. Something claim H naught and H alternative. In the exam, you write down on your sheet, you can write null hypothesis. Instead of H naught, you just write null hypothesis. So I'm writing so that you can also make a kind of practice on that. Where is that good one? This is the good one. So I'm writing null hypothesis. Null hypothesis and alternative alternative hypothesis. There is a claim that it differs, right? It differs from the reported average of the 5.4. So mu is given, right? Mu, I'm writing mu. So what is the null hypothesis and what is alternative hypothesis? Anyone? Is that correct?
For null, it's mu equals 5.4, and for alternate, it's mu equals does not equal 5.4.
Exactly. 5.4, 5.4. You need to write in the same way on the documents. So there is no notation in terms of mu and all. You see, I made it plain and simple. Instead of writing H naught or HA, writing in the full null hypothesis, alternative hypothesis. Mu, instead of the notation mu equal to 5.4, mu not equal to. So this way, if you are writing, you will get full marks for the formulation of null hypothesis and alternative hypothesis. What is next? So there is a claim at 95%. Alpha value is given 0.05. For a sample n equal to 8, sample mean x bar is given 7.16, and capital S is given. The standard deviation of sample is given 3.56 hours. 3.56 hours. What else you need? So in this case, how to get the T stats? Use the formula here. Okay, let me share with you. This is the formula, right? This is clearly the case of T stats. It's talking about the sample where standard deviation is not given. So standard deviation of population is not given. So instead of that, capital S, standard deviation of sample is given. And we know that the right formula to use in order to calculate T stats is x bar minus mu naught divided by S capital Y as divided by root square of n with the degree of freedom n minus 1. Did you get that? This is the right. Do you think that this is the right formula to use?
Yes.
Because we have all the information which I've kept it here. It will be used for having a calculation for T. So what is the T stats in this case? T stats is x bar minus mu naught. Where is x bar? 7.16 minus mu naught here. Mu naught. This is mu or mu naught? It's better you write mu, no problem. 5.4 divided by capital S is again from here 3.56 square divided by square root of n. N value is 8.
Wait, sir, I thought x bar was 5.4.
No. Read the question once again. No, x bar is a sample, right? Sample mean is given how much? 5.6, right?
Isn't the sample mean 7.16? So that's mu, and then x bar is 5.4.
No. X bar is for sample. And mu is a sample. Mu is a population parameter.
Okay.
Remember the first slide we started today?
Okay.
The sample statistics are x bar and capital S. And the population parameters are mu and sigma.
Okay.
So don't get confused, otherwise you will end up with wrong answers and all the wrong interpretation. I think this is the correct one. So You get the value of t? What will be the value of t here? T statistics value you will get 1 point. Anyone? It will be 1.398. And what is the degree of freedom?
7.
Exactly. And minus 1, 7. So you got the T stats and DOF. What is the next? Remember that p-value less than alpha, p-value greater than alpha. So remember the golden rule: if p is less, H naught must go. P is less, H naught must go. This is the golden rule. So p value is less than H naught must go means reject H naught. Otherwise, not reject H naught. With that note, it's important. You should never use the sentence like we should accept. So p value less than alpha, reject H naught. P value greater than alpha, not reject H naught. H naught. You should never write accept H naught. No, there is nothing like we are accepting null hypothesis. So you should never write accept H naught. Instead, you have to write not reject H naught or reject H naught. So p value is less. This is the golden rule. P value is less, H naught must go. Must go means reject H naught. What is the p value then? For degree of freedom 7 and the t value 1.398. What do you think? What is the p value? Can you use the table and get the p value? Alpha is 0.05. Can anyone try? P value. Rina, are you there?
Yeah.
Yeah, you said something like, can you give some examples? Examples?
Oh, yeah, that was at the beginning of the lesson.
Okay, did you get it?
asked
Okay.
us
Oh, I'm
if
sorry.
there
So
was any-
all clear now, right?
Yeah.
Okay. I thought suddenly I saw that, so I thought.
Oh no, I meant like the overview when you start asking about, the PowerPoint and if there was any problem.
Okay, so all good now. Okay.
Yeah, but now you're providing examples, so that's
Okay. Yes, that's what, as a revision we are doing it. I'm trying to have one question from each one, so that is like I'm trying my best so that you can have a kind of recap, especially one question from each concept which we are talking about from week 8 to week 2. So, Rina, can you suggest me what is the p value for here? For the t stats value 1.398 with degree of freedom 7, what is the p value?
Can you please share the table?
Okay. This table you are looking for?
Yeah.
Okay, so degree of freedom 7. So degree of freedom 7 here. And then
0.1,
0 point.
1.
Okay, you are saying this one. Let's say I'm looking at this one, right? Which I circled.
Mm-hmm.
Okay, so 1 point. Yes, exactly. 1.398 is closer to 1.415 at 7 degree of freedom. As Rina rightly said, the p value is 0.10. And this is the case of one tail or two tail. So what is the final p-value?
0.2.
Exactly. This is the two-tail test. Remember, it's not equal to. So it's a two-tail test. So in this case, exact p-value will be twice. So the p-value is 2 into 0.10, right? 0.10. So the p-value is coming 0.20, which is greater than alpha 0.05. So what is the conclusion here? What will be the conclusion on the basis of this one? We should not reject null hypothesis. I mean, we should not reject null hypothesis. So we got a support for the null hypothesis. That means the claim was it differs. We have not found any support for that. Means we have a support for 5.4. A claim was made that this sample differed from the reported average of 5.4. We have received any support for this claim? No. So what is the conclusion? The sample is not differed from the reported average of 5.4 hours. So we have sufficient evidence that the sample average is not differed from 5.4 hours. Is that clear?
Could you say the statement again?
We got at 95 at the 5% significant level, we have where is the statement exactly? Yeah, okay, over here. You see the statement here?
Yeah.
Okay, so since p-value is greater than, since the p-value, two sentences in the statement, p-values is greater than, p-values 0.20 is greater than 0.05. So we will not reject null hypothesis. That is one sentence. And then the second sentence, you conclude that there is sufficient evidence that the mean of what is mean value of reported average weight. There is a sufficient evidence that the reported average is 5.4 hours.
The reported average for the sample.
Not for the sample. You should not write the sample here. The claim, original claim, like US mobile phone subscribers has average 5.4 hours per month. So not for the sample.
For the population.
Exactly. We are using the sample to support.
Yeah,
we are making the inferences for the population. So always look at the sentence clearly, nicely. What is the claim sentence, alternative hypothesis? And then around that only you have to write the second sentence after either rejection or not rejection. After the second sentence, you just frame, it has to be around the claim. What was the original claim? That it differed? No, we got a sufficient claim support for the no difference in the original claim, something like that. So it should revolve around. And I have given you 2 or 3 different templates to how to write the conclusion. So hypothesis testing. Okay. For the single we have seen single population mean. Okay, we have one more exercise for the hypothesis here. So this one was t-test. Let's see another example with the Z statistics. So exercise number 8. For the jet test for the single population mean, where the sigma is known. Go through this example. In the Oxford serial case, suppose that the sample of the 25 serial boxes indicate a sample mean X bar is 372.5 grams. And the population standard deviation, so sigma is given 15 grams. A claim was made that the mean is different from 368 grams. Do you think that you have a support for this claim? Go through and try to solve this one. Try to go through the step by step. Claim was made that the mean is different from 368. So mu not equal to 368 grams. That is your alternative hypothesis. That is the claim. So the null hypothesis is mu equal to 368 grams. Clearly, this is the case of two-tailed test. Alpha value is 95, 5% significant level, so 0.05. What is the n value? Sample of 25 serial boxes, so 25. The mean X bar is given 372.5 grams. And the population standard deviation sigma is given. Sigma is given, instead of S, sigma is given 15 grams. So it's easy to find the Z statistics in this case. So what is Z statistics? X bar minus mu naught divided by sigma square root of n divided by square root of n. So X bar 372.5 minus mu. Mu is from here, the null hypothesis. It's a 368 divided by sigma is known 15 divided by square root of n 25. What value you will get? 68, 72, 4.5 by 15 into 5.
1.5.
Yes, it's clearly the case of 1.5. We will not talk about degree of freedom over here. It's a Z states. Now, you need to see in this case, you need to find the critical value now. Going back to the critical value now. At alpha 0.05, what is the critical value?
1.9.
1.96?
96. Yeah.
Okay. So we'll see that here is the critical value. You guys are able to see that? See, the different sums requires a different sort of analysis, different way of analysis in order to see the p-value, or in order to see that area of rejection or not rejection. So over here, so 1.96 minus 1.96. These two are critical value, CV. Critical value, CV at 0.05. Use the jet table, you will get this value 1.96. And what we understood before, this is the area of rejection. This is again the area of, outside is area of rejection. Rejection means reject H naught. Whereas inside, in this area, this is area of non-rejection. Non-rejection. What is the Z value we get? We got the Z value 1.5. So critical value 1.96. Our Z value will lies where? 1.5. So 1.5 will be inside, somewhere here. So 1.5. Since 1.5 falls under the area of non-rejection, what we will say? We will not reject. So what will be the your conclusion? We will not non-rejection. So we will not reject null hypothesis. Not reject null hypothesis. Again, we got a support for mu equal to 368. So we have sufficient evidence that the mean value has not changed from 368. Not reject H naught means we got a support for our null hypothesis. So no support for the alternative hypothesis. I think, yeah, probably you can have this one. Bit different sort of analysis using the area of rejection and non-rejection. Why I can't make bigger? I don't know. Did you get the critical value? I think we know that 1.96 at the alpha 0.05. We have seen previously also for 99%, 95% and 90%. For 90%, 1.64 is the critical value, 1.645. For 95, it is 1.96. And for 99%, it is somewhere 2.13 or something. So these critical values are known to us. Otherwise, you can use the Z-score table. You will get the critical values 1.96 for alpha 0.05. So 1.96 in the left image, you can see that is the critical value, minus 1.96 and plus 1.96. These two are the critical values, which clearly separates area of rejection and area of non-rejection. So inside two areas are non-rejection and outside two areas are rejection. Rejection of H naught. It is not written there, but you need to understand. We are talking about the rejection or non-rejection of null hypothesis. And then we have seen the 1 plus 1.5 falls under the area of non-rejection. So clearly it says that because the Z value plus 1.5 is in between 1 minus this range, so you should not reject H naught. And you see the conclusion. You continue to believe that the mean fill amount is 368 grams. And the conclusion, you state the conclusion as there is a sufficient or there is an insufficient evidence that the mean fill is different from 368 grams. Otherwise, another way, there is a sufficient evidence that mean fill is 368 grams. Both are right. Either in terms of insufficient or either in terms of sufficient, both are right. So you can say there is a sufficient evidence that mean fill is 368 grams. Fine. Otherwise, there is insufficient evidence that the mean fill is different from 368 grams. Does that make sense? Both the statement?
Yeah, they do.
So both are same. So either way, you can use any one. Saying sufficient evidence or insufficient. Sufficient evidence means you will directly link to the null hypothesis. But insufficient evidence, you will link with the alternative hypothesis. Both way are correct. So as a part of hypothesis testing for the single population mean, we have covered two different varieties. One is the case where sigma was known, the previous case, and the second case just now we have seen sigma was known. Any doubt till this point of time? Anyone? Any doubt to anyone? I don't know, like initially I was thinking also, like after in the second half, I was thinking that maybe it will be difficult for me also to communicate you all these concepts, but probably you guys have attempted more and more. You worked really hard in order to understand, and that's why today I can see that most of you are more comfortable with all these concepts. It seems to be a kind of win-win situation. You guys are happy giving answers and seeing that you are on the also like right sort of thinking, right way of, you're on the right way of thinking. And ultimately, I'm happy because you guys are learning.
I have a questions.
Please go ahead.
Yeah, is this PowerPoint going to be a Moodle?
This is the same thing. Okay.
It's not. It's different.
No.
Because the one on Moodle, it doesn't have exercises. It's quite different.
No. How can?
Yeah.
Yesterday, okay. Maybe you have taken the wrong. Means you have taken the old one, not the updated one.
Yeah, I just logged in, but like it's not the same, so I'm not sure what's.
Can you please re-upload the PowerPoint? I don't think ours is updated.
Yeah.
Let me upload now itself then. No worries.
Thank you.
Just now let me upload because. Yes, you can download now and see why I was not willing to upload because it's around 200 slides. So I thought, What I did yesterday, just I copied all the content from week 8 to week 12 and I put in the another one new slides. Nothing, apart from that, nothing changes I have made. So you can download it now. From the Moodle.
Yeah, got it. Thanks.
Yeah. I'm uploading for the second section. We have 2 different sections. So yeah, it's done for both sections. So okay, going back here. So now quickly we will move to the more hypothesis testing. So next, okay, week 11 we have covered more about the hypothesis. I mean to say, like, we included the independent data and dependent data variable. So I have decided to go ahead with one example here. That is exercise number 2, slide 113. But do you have any difficulty in understanding the dependent and independent?
Yeah.
Proportion, as it is clearly mentioned, hypothesis, it's not a part of your final exam. So okay, that example will be more suitable for the correlation. Okay, dependent and independent data. In the simple experiment setup here, where we have 2 different groups, one is experimental group and one is control group. Clearly these are independent. So if you are doing the comparison just before the treatment, so first data collection before for the experimental group, or the first data collection for the control group. This is the case of what? Independent t-test, right? Because these 2 are the independent data. So this is the separate t-test, but independent separate t-test. Or we can do the same analysis after the treatment for both the groups. Both the groups are different, independent, but we are taking the data for after treatment for both the groups. So second data collection for the experimental group or second data collection for the control group. Clearly, this is the case of independent data, right? Not dependent data. But you can think about the dependent data in this case also. If you look at the relationship vertically, not horizontally, in the same experimental design. So suppose in the second case, I'm talking about now dependency. I think we have the slide for the dependency, where we will see the vertical relationship. Yeah. Now we are interested in knowing the vertical relationship of one particular group, experimental group. Get rid of the control group, or otherwise just think about control group, get rid of the experimental group. So in the dependent one, we have only one group, but two types of data. One is before the treatment data for the experimental group, and after the treatment, second data collection. So if you do this sort of analysis for one particular group, this is the case, clearly this is the case of dependency. Because the same sort of respondent are there from whom you are collecting the data before the treatment and after the treatment. Before the doses, after the doses. Before the training, after the training. Before the statistics class, your performance. After the statistics class, your performance. It's a dependent one. Within the same group, same respondent. We can do the same thing for the control group as well. Before the treatment, after the treatment. So clearly this is the case in this sort of analysis. In the same experimental design, you could have independency and dependency. So the question you need to be you need to clearly analyze that. Is it the case of one sample mean or more than one sample mean? Clearly, if this is the case of dependency, it will be more than one. One will be dependent on other, or before or after. Having treatment, not treatment. So having exposed, not exposed. So clearly this is the case of more than one mean, not a single mean. And probably the data will be given in exam will be N1, N2, X1 bar, X2 bar, capital S1, capital S2. So that clearly gives you indication that this is not the case of single mean, it's a more than one mean. And if it is a case of more than one mean, means look at, is it a dependent data or independent data? So I have one exercise here, exercise number 2, slide 113. As I said, in the exam paper, it will be clearly mentioned that if it will be a case of, the equal variance or not equal variance. But remember, if there are two different samples, like one sample is from male and one sample is from female, do you think that variance will be equal? Unless until it is not stated it's equal, you need to consider as a separate t-test. It's very rare, or otherwise it will be clearly stated if it will be having an equal variance or pooled variance. So if it is not mentioned, it means you have to consider it as a separate t-test for the independent group. So in this case, what is given here? You are a financial analyst for the brokerage firm. Is there a difference in the dividend yield between the stock listed in the two different stock exchanges? One is New York Stock Exchange, and the second one is NASDAQ. Both are from US. And what is given to you? Sample statistics. I mean to say sample statistics, two sample statistics, sample mean and sample standard deviation. Sample mean, the notation is X1 bar and X2 bar. Whereas the standard deviation, sample standard deviation, capital S. So capital S, S1 and capital S2. And numbers, N1, sample size, N1 and N2 is given to you. Assuming both the populations are approximately normal, and especially in this case, it is given equal variance. So pool variance, this is the case of pool variance, equal variance. And the claim is there any difference in the mean yield or mean return? Is there any difference between these two stocks? Like you have one, so suppose you have stocks from NYSE, whereas your friend has stocks from NASDAQ. And you wanted to see, somebody wanted to have a comparison. That is there any difference between the mean return from these two stock exchanges? So clearly this is the case of independent, the sample from NASDAQ and sample from New York Stock Exchange. They will be different, right? So this is clearly the case of independent one. But given that, because it is given, we have to assume that. Given that equal variance, we'll go through the second case. So what is that? Pooled variance t-test, not the separate variance t-test. How to get the t statistics? X1 bar, no, very important here to formulate the null hypothesis and alternative hypothesis. Since the samples are two different values of mu1 and mu2. So don't write here in case of in the exam, if the question will be to write a null hypothesis or alternative, don't write mu equal to 0 and mu not equal to 0. You will be absolutely wrong. Because this is two cases, the cases are two different means, you need to write mu1 minus mu2 equal to 0. Otherwise, mu1 minus mu2 not equal to 0. For calculating the t-stats, you have x1 bar minus x2 bar. minus mu1 minus mu2. Remember, mu1 minus mu2 will be not given in the question because your null hypothesis you set in such a way that this value is always 0. So in short, your actual formula is just x bar 1 minus x bar 2 divide by blah 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 whatever you have in front of you, sp square, that is known as the pooled variance. That's why, because of sp only, the name is also known as the pooled variance t-test. Pooled variance t-test means with the equal variance, the case of equal variance. And in case of unequal variance is the separate t-test. And you have the separate formula for calculating sp square. N1 minus what, like you just be careful in terms of calculation, nothing. And but in this case, the pooled variant t-test, you have the different way of calculating DOF, degree of freedom. Two different sample means N1 plus N2. So your degree of freedom is N1 plus N2 minus whole minus 2. But just a quick one. In the separate t-test, I found that the formula for calculating the DOF, degree of freedom, is a bit cumbersome, bit complex. So I have this what if this will the this sort of question will be part of your exam, end-term exam. The DOF will be given to you, so you don't have to worry, especially for the calculation of V, which is in front of you. So don't worry. If this will be in your paper, this question will be separate variance t-test will be in your paper, then the value of degree of freedom will be given to you. So you don't worry about the calculation. You just have to worry about calculating the t statistics, which is simple to calculate. X1 minus x2 bar divide by s1 square by n1 plus 2 square whole square. Does
Thank
that make
you.
sense?
Yeah, it does.
Yeah. So don't get disheartened in terms of anything. Let me know what is the problem, because I came to know this one from some of you, that you're getting a kind of each and every time you're facing difficulty in terms of calculating DOF. So I decided, okay, go ahead with the kind of this one. Just hang on. Some background noise is coming. Sorry, there was some background noise. So I requested them to stop. So don't worry, as I said, DOF will be given to you. Only for this case where I found that there is a difficulty. Otherwise, for other cases, DOF will be easy to calculate. So how to get the T-stats? Using the same formula. You got the T-stats for this sum, so this exercise 2.040, whereas the pooled variance SPA square is 1.5. So using that, you got the T-stats 2.040. And then we understood the area of, again, the area of rejection and non-rejection, you see. Either you can do it by this way, or you can calculate the p-values and just. So the T-stats value 2.040, whereas the critical value is 2.0154. So 2.040 lies in the area of rejection, outside area, your T-stats. So clearly we reject the null hypothesis at alpha of 0.05. So your conclusion is there is a sufficient evidence that there is a differences in the mean value of the returns of these two different stocks. Calculating the DOF, degree of freedom, is easy. N1 plus N2 minus 2, 21 plus 25 minus 2, that is 44. So you need to be careful in terms of formulating the null hypothesis and alternative hypothesis, especially in the case of independent and dependent sample of means. Any doubt here?
Sir, for this exercise, is there still such thing as the p-value? You're
Yes.
just yeah, you're just showing us this graph because the p-value and the alpha come out the same, right?
Yes, both the way you can do it, but I think t-stats you can use the critical value also. I think this is more, this will be more appropriate and your like more time saving. You
Okay.
just look at the t value from the table, that is the critical value, and then you just see where is the t stats which you observe, like 2.040 where it lies. Both
Okay.
ways are correct.
Okay. Thanks.
Both, because we have seen somewhere like sometimes we use the p-value, sometimes we use kind of area of rejection and non-rejection interchangeably. Like wherever you feel comfortable with, you just go ahead with that. It has to be logical, I mean to say. Both ways are correct. There are other two more ways are there in the book. If you go to the advanced level of statistics, there are, I think, all around four different ways of having a comparison in the stage 4 or 5, where we take the decision of rejection or not rejection. So there are two other ways are there, but that is will be covered in the advanced stage, but not now. I thought to stick to the one way, that is the p-value one, but sometimes it got failed. So I jumped to the second one, and I introduce you the area of rejection and non-rejection. I know, like I was also struggling sometimes, some point of time. That's why I thought, okay, at least two ways I should introduce to you. So just, but both ways will give you the right answer. Nothing wrong in that. But with the expertise and with the time, if you feel like more comfortable, then use interchangeably. It's fine, because both will give you the right sort of decision making and a right sort of support for the claim, or either for the claim or not support for the claim, and your final answer or interpretation is not going to change. It will be same. So you will get a good marks, the right marks for while applying both the ways of interpretation. Fine. And there is a case of dependent one, which we have seen the vertical relationship over here. So in this case, what I found that, yeah, if the t status, if suppose the question will come from this one, the matched pair or the dependent data, again the value of d bar or sd will be given to you. Mu d is always 0, that is your null hypothesis. But the value of d bar, the mean value of difference, and the standard value of the mean difference, both sd and d bar will be given to you in your exam. So you don't have to worry. You just have to find, apply, because it's more example, like exam is more about application, not to unnecessarily put you on the calculation work. So d bar and sd will be given to you if there will be question from dependent pair data.
Sir, how will it be given to us? Will it be like stated, or will it be in like an Excel sheet?
No, Excel sheet will be, it will be clearly stated. T bar is 14.64, SD will be 0.75. It will be clearly stated.
So D is the difference, right? ST is the popular standard deviation.
Yes, yes, yes. We have seen here that over here, both D bar and SD is like belonging to the fourth column, that is difference. Like -2, -14, -1, 0, and -4. If suppose this 5 data is given to you, if you take the mean value, it will come -4.2, and the standard deviation will come 5.67. So that is the fourth column. The D bar and SD values are just for the fourth column. And fourth column is the difference between the third column and second column, after and before. So 4 minus 6 minus 2, 6 minus 20 minus 14, 0 minus 0, 0, 0 minus 4 minus 4. That clear? You have one data before the training, after the training, before the exposure, after the exposure, before the treatment, after the treatment. So two dependent data for the 5 different person, for 5 different clerks, for 5 different executive, for 5 different patients, for 5 different students, whatever. So you got the difference in the fourth column, 2 minus 1 difference, and D bar is the mean of those difference. SD is the standard deviation of those difference. So on the basis of that, you just apply the t-stats. You got minus 1.66, and then you just go ahead with the final conclusion. Where it lies? In this case, minus 1.66 lies in between area of non-rejection. So you should not reject H naught. So the conclusion is there is not a significant change in the number of complaints, or there is no significant change in terms of providing training to the clerk, or there is no significant difference in terms of giving statistics to the NIC students. So whatever, on the basis of your research objective, you'll make a conclusion. Wanted to see, is there any impact of that treatment, impact of that exposure, impact of that training, impact of that classes, sort of comparison, and wanted to see, is that significant, that change is, impact is significant or not. That's why we are doing the hypothesis testing. Make sense? So hypothesis testing for the proportion is not in this final syllabus. Any doubt till now? Or all clear?
Sir, sorry, can you just show the previous slide, just to see if the last exercise if we reject. Okay. Yeah. Okay. Thank you.
So in the case of independent and dependent, only 3 varieties we have covered. 3 different sort of concept we have covered. One is independent t-test. No, I mean, separate t-test for the independent, pooled variance t-test for the independent, and the third one is dependency, dependent value. So in that case, we have seen the mean of difference. That mu d, you remember that mu d. You should not write anything in terms of, suppose in this case, formulate the null hypothesis and alternative hypothesis. You should not write mu equal to 0 and mu equal to not equal to 0. It will be meaningful. Like it will be not meaningful, I mean to say. Because the mu is also referred to the single population. We have seen mu value is the mean value of the population. So instead of writing mu d equal to 0 or mu d not equal to 0, if you are writing mu equal to 0 and mu not equal to 0, probably you will get 0 marks. Because the way you have written down, the way you have formulated the null hypothesis or alternative hypothesis is not correct. Because the D word itself has some meaning here. And what is that? The average difference. That's why you have written here, the average difference in the population equal to 0. That is the interpretation for mu D. So in the case of dependency, we always talk about difference. Difference means before the treatment, after the treatment. These 2 values, what is the difference? We are just interested in knowing the differences. Before the treatment, after the treatment, before exposure, after the exposure. Before the classes, after the classes. So that difference has some meaning. And that's why in the null hypothesis, it is mu d equal to 0. So even if you're writing in the document, Word file, just you have to write mu bracket d. I will understand that. But don't write mu equal to 0. I will not able to give you the right now. So be careful in terms of formulating null hypothesis and alternative hypothesis for all the sum. Because because the different notations will be there based on the different sort of exercise, with different concept involved in that exercise. There are different notations. Like we have seen in the case of 2, it is mu1 minus mu2 equal to 0, mu1 minus mu2 not equal to 0. So simply writing mu equal to 0, mu not equal to 0 for the 2 mains will be incorrect. Probably in this exam, I'm not going to ask you about the requirement. We could have done it when doing the proper face-to-face class test, kind of in the proper setting where you could have thought to hand over me the hard copy handwritten. I could have gone through the like all the 7 steps for calculating the hypothesis testing. But fortunately, you are safe this time because I'm not going to ask you anything about requirements, does it meet or not, because the kind of question I have said, I'm assuming that it is going to, and you should also assume that those criteria are fulfilled. So just go ahead with that calculation, give the values, findings of the t statistics, p values, and do the calculation, have an interpretation. So no need to worry about the requirements. Assume that it's going to fit. That's why the question is coming to you. But these are important. If you could have given in writing all the 7 steps and all. Just a kind of small repetition once again. I have suggested you many times. You should not use the Excel sheet for any calculation. Just let me see some noise, background noise I'm getting here. Okay. So what I was telling that you should not use the Excel sheet for any calculation. There is a slight difference between your manual calculation and the output which Excel sheet gives. Maybe in terms of confidence interval estimation, maybe in terms of getting the t-stats value or the p values, or so there is a slight difference always. And we have seen that. It's not like that much of a difference which will give you the wrong direction or wrong answers, but there will be slight difference. And since I'm asking you to provide all the results with the 2 decimal points, so I will suggest you to use the manually. Do it manually and give the answer. So be careful on that one. Should not rely on the Excel output or the output from the Excel sheets. Since we have another 5 minutes, I will not go through the exercise related to correlation and regression. We have 2 hours remaining in the tutorial. And if I could remember, in the week 12 exercise, we have only covered question number 1 and question number 2. So, okay, the remaining 2 questions we will cover in the last tutorial classes on the Friday. And probably some of the questions, the way I have taken you like today, all the exercise, you will see that most of the questions will be around this discussion. That's why that was my purpose. So I'm trying to give you a kind of questions which I said. So somehow you're getting a kind of glimpse of what sort of the question will come in the exam also. So just in the tutorial class, we'll cover the exercise 3 and 4 from the correlation and regression. I found like still some of you are struggling to understand what is correlation and what is regression. How I will come to know that is it a regression or correlation? So I came to know after having a discussion with some of you. So what is like, when you think about it's a correlation, or when you think about it's a case of regression? Anyone? When you think it's correlation or stuff, or it's a regression stuff, can we do this sort of analysis? That which case is the regression or which case of the correlation? Is it a meaningful question I'm asking? Is the right question I'm asking, or is it something different has to be there? Anyone can jump in and speak. Is it something like a situation of correlation or a situation of regression, or how do you think about these two concepts, correlation and regression? Anyone, can you jump in and speak? No? You can try. No, no one wanted to share anything. What is correlation then? Thomas, are you there? Thomas? Wait, unnecessary. Khan, are you there? Ahab Khan.
Yes.
How you see the concept of correlation and regression?
Correlation is the relation between two or more, like two things, or the relation between X and Y.
Mm-hmm. Good, Israt. Yeah, go ahead.
And regression, I'm not sure about regression.
Okay, just take an example of like, one is suppose Alexandra is here and Israt is here. Both are the students from NIC, right? Can we say there is a correlation between these two students?
Yeah.
What is the, like, how you can say it's a correlation? Because they are friends?
No, we are the students of same place.
Institute, yes. Since you both are, Israt and Alexandra, both are the students from NIC.
Yeah.
So there is a correlation.
Yeah.
But we can't say that one leads to another one. I mean to say, can we say that happiness in Israt leads to happiness in Alexandra?
Nope.
Because we are, see, these are two different concepts. I mean to say, correlation has a different objectives. It's a limited one. You're just trying to see the correlation. Is there any correlation between Ahab Khan and Amit sir? Yes. Because in one of the settings, they were having a kind of a student and teacher's relationship. That is, they are just correlated, but we are not saying that one leads to another one. Happiness in one person leads to that happiness person leads to one person leads to happiness in another one. That sort of analysis will be a regression, where we wanted to see the causal relationship. Does A cause the happiness in B? So the regression has a different purpose altogether. Don't mix up. Maybe when doing the regression, the first step itself will be to analyze the correlation. If there is no correlation, we can't say the causal relations. We can't establish the causal relationship later on.
So regression will have an outcome, right?
Yes, like one will be independent and one will be dependent. Something will lead to something. We are interested in the relationship, like how one changes in one relationship leads to the changes in second relationship.
Okay.
But for the correlation, just a kind of, coincidence that two people somewhere they met and they are correlated.
Mm.
So on those lines, try to think, build up, start thinking about that one.
Yeah.
Does attending the statistics class leads to the improvement in the logical thinking or critical thinking of the students of NIC? So one is independent and one is dependent. What is independent here? Attending the NIC statistics class. And what is the dependent one? I wanted to see the improvement in the performance or improvement in the logical thinking, improvement in the critical thinking. That is the dependent variable. So that is the case of regression. Whereas the correlation is just a coincidence that more than two persons, more than two objects, more than two elements are correlated to each other. But if they are correlated, we can't say it's a causal also. That one changes in one will lead to changes in others. And the correlation has like simple meaning, but the regression has a very, very large importance, large impact in the day-to-day activities. We are always interested in knowing that does this leads to this one. We are always, does the happiness inside the organization leads to the better performance, more dedication of the employees, more commitment from the employees? Or does the incentive program in the organization leads to the more commitment in the employees? So does one lead to another? That is the regression. That is the causality we are trying to establish in between the two different variables. So read more and more on the correlation and regression, and in the tutorial, as I said, we will cover the remaining two exercise 3 and 4 from the tutorial tour. Thank you, those who have participated today in the discussion, and if anything else, just tell me, otherwise we will close today's session. And hope all the sort of revision which we have did improves your understanding, has improved your understanding. I'm sure, I'm hoping that. So I hope everybody has responded to the chat box in terms of the attendance, and I kept it safe now. And just let me know any further doubt, otherwise I will close this session because I have another classes from 1 o'clock.
Sir, we will be able to do the calculations on the paper in finals. And then if we just put the answers on the answer paper, it will not cause any trouble, right?
As I said, one blank page will be allowed to you. I mean, just do the manual sort calculation and just put it.
Okay, yeah.
But don't make a lengthy calculation on the paper. One blank sheet, keep in mind that just make a small calculation just to assist you, so that you will not get distracted in terms of where was the first part, where is the second part. So just for your help only, keep yourself with the one blank page. Otherwise, and if there is a requirement, if you think that it's meaningful to use paper, if not, then just go ahead with that one. There is no need. Don't.
The paper will be easier, like as we are practice on the paper.
Yeah, especially calculating the t-stat.
Yeah, calculating those stuff are like really hard to do on the word. That's the
Initially, I was not able to understand that, but with you guys having a discussion, I came to know that it's important. So I added that one and I communicated to the NIC.
Like usually, like mostly we did the calculations on the paper and then just wrote the answers on the answer paper.
Yeah, I understand that. So I mean to say, keeping one page, blank page will be fine. Both the pages, keep it blank. In case if one blank page is over and all, you just ask them, can I take another one? It's up to you. But I hope one will be fine. So try to make a small calculation, like use the small font to have a kind of calculation on the blank page.
Okay, yeah.
So
It would be helpful if we could even like have the printout of the Z table and T table. Like,
since I said to you, it is clearly mentioned that it is a closed book, and the table is given in the answer sheet itself, like question paper itself. So I will suggest you not to take the printout. Unnecessary, it will create confusion. Then it will be difficult for you to manage. So it's like just manage. It will be okay on seeing on the screen. And as I said, actually the question paper which I said, you will be able to solve within 1 hour 20 minutes. So think about 40 minutes is just like kind of revision and all.
yeah.
Okay, just wanted to be sure that it should not create any confusion to any of the invigilators. That is my concern. If you are able to manage, just do it. But keep in mind, it's a closed book. That's why it is clearly mentioned that it's closed book. So any printout and all unnecessary will be like if it is there already on the screen, why you're so just try to get habituated. If I think it will be fine for you.
Okay, yeah.
Okay, with that note, I'm closing today's discussion and see you on then Friday in tutorial. Bye. Take care.
Okay, sir. Thank you. Bye.